Whenever you're working with fractions, there are two conditions that have to be met before you render a final answer to any problem. One is that the fraction must be reduced. The other is that the fraction must be proper. So if you need the definitions of those in detail, I encourage you to look them up again. Reducing a fraction simply means that you have put it in its lowest possible terms, or it is reduced to a state in which it could no longer be converted to an easier or smaller number. So reducing a fraction means that 50 over 100 is the same as 30 over 60, which is the same as 10 over 20, which is the same as 5 over 10, which is the same as 1 over 2. All of those would be incorrect because they simply leave us with much larger numbers than we need. And so for all of our arithmetic functions as they relate to fractions and reporting answers, it's only proper or only appropriate to give your final answer in this setting right here, where it's been reduced to its lowest possible terms. Now let's look at an improper fraction, what it means to convert that. So by its very nature, when you hear the term fraction, you think of parts of a whole, correct? So if we have a whole pie and we have fractions of the pie, what we're actually saying here is that this is one piece and this is one piece and this is one piece. But it's a fraction because it represents less than the whole pie. So this is less than the whole pie, this is less than the whole pie, and this is less than the whole pie. It would be an improper fraction to say, I have my same pie, but this time instead of having 2/3, I want 4/3 and a peace sign, apparently. We can't have 4/3. We only have one full pie, and these then are not thirds. So in order to make this a proper fraction, what we have to do is we have to make sure that we've accounted for the fact that this is no longer a fraction by itself. It's actually a whole pie plus a fraction of a pie. So we can't leave an answer in a case like that. We can't leave an answer of like 3 over 2 because that is essentially saying we have 3 halves of a pie. And you wouldn't say you have 3 halves of a pie. You would say that you have 1½ pies. So proper fractions or improper fractions have to be made proper before they are rendered into the final answer. And they have to be reduced as well. In many cases, you actually have to do both. So let's do one reduction by itself, one conversion from improper to proper by itself, and then we'll do one that deals with both. So reducing a fraction, there is a little bit of a trial and error method there. A couple of things to remember to make it easy. Even numbers can always be divided by 2. So in other words, you will never have an even number in both positions. If you have 2 over 4, if you have 6 over 10, if you have 8 over 18, if you have 24 over 148, all of those can be reduced because all of them can be divided by 2, at least divided by 2. Now, it's much easier for you to try to reduce a fraction to its lowest terms by using something other than 2, simply because 2 means you may have to divide that problem out over and over and over again. But it's reliable to do it that way. So what I mean is it may take you longer than you want, but it will always get you to the right answer. So if we had if we had 240 over 320 and we wanted to reduce this fraction, one way, probably the easiest way to do it, is to say that when we have a 0 on both sides, we know it's divisible by 10. So we could divide each side by 10. If we know that, that's great. If we don't know that, what we can actually still go back to here is that we know that this is an even number on both sides. So we can do 240 divided by 2, and we can do 320 divided by 2. Does 2 go into 3? Yes, it goes in 1 time. Does 2 go into 12? Yes, it goes in 6 times. Okay, does 2 go into 0? Okay, so there's your answer there. If we do our 2 and 240, does 2 go into 2? Yes, it goes in 1 time. Does 2 go into 4? Yes, it goes in 2 times. Does 2, okay. So we have 120 over 160. Okay. So again, it would have been much easier to do that by doing it with a factor of 10. But what we could do if we had to is we could just keep dividing by 2 again and again. Be a lot of division problems, but we would still get to the right answer. So that's a reliable method to get you the right answer, even if it's not the most efficient way to get you to the right answer. Now let's look at an improper fraction. Okay, so let's say you've done your math and what you've come up with is an answer of 3 over 2. You know that you can't address this, can't leave the problem in this, or the answer in this format, because the numerator here is greater than the denominator there. So what you can do is simply convert this to a decimal. Just go back to exactly what you'd been doing before. So this is 3 divided by 2. So 3 divided by 2. Does 2 go into 3? Yes, it does, once. That leaves you with that. And we put in our decimal place, bring us down to, does 2 go into 10? Yes, goes in 5 times, and then we're left with 0. So 3 over 2 becomes proper by making it either 1.5 or 1 1/2. Okay, so let's look at one last problem in which we'll both convert and reduce. Okay, so let's say you've come up with a final answer of 16/4. And now you need to both convert this to a proper fraction and you need to reduce it. So to convert it to a proper fraction, we're going to do 16 divided by 4. Does 4 go into 16? Yes. It goes in 4 times and it goes in evenly at 4. So to convert the improper fraction to a proper fraction, what we've essentially done is we're able to just come up with a straight 4. Now, if we had to, we could have reduced this problem first, and we would have come up with the same answer. So if we had, let's say we had 16 over 4, and we wanted to reduce it, like this. So 16 divided by 2 is 8. 4 divided by 2 is 2. So if we were going to convert this improper fraction, here's what happens. 8 divided by 2. Does 2 go into 8? Yes, it goes in 4 times. So we come up with our 4 if we reduce first or convert to proper first. It doesn't make any difference mathematically. I encourage you to do whichever one is best for you in terms of the numbers that you're comfortable working with. Most of the time, reducing the numbers is best because it keeps your arithmetic less complicated when you actually start to do your division problems, but it'll truly work either way. So that is problem 10, 11, and 12.